Improving is sponsoring today, so we're at the Improving office. That's why you'll see us with pizza. I'm hoping we can have more in-person sessions soon and get on a rhythm now that things are getting back to normal. We did send out a survey, so if you have any suggestions or anything, you can send us a note through Meetup or respond to that survey. I'll check to see if we sent that out to everyone or if we can send another one out after this meeting. And then just for attending today, you do have a chance to win a prize. In the back, Garrow is going to be doing some random drawings. So you have a chance, whether you're in person, we have, including Claudio, there's 5 of us here, Garrow, so keep that in mind. And then we have everyone, yes, 5. And then we have everyone virtual. So Garrow's got everyone down. He might be sending you a message during the meeting. So if he does, please respond to your email so we can contact you afterwards to send you your prize. Again, great to see everybody. If also, another item I just wanted to bring up, if you would like to be a speaker at any of our future meetings, or if your company is interested in sponsoring, please send us a note. We would love to have you speak or sponsor at our meeting. Thank you so much, Improving, for sponsoring today. And we have Claudio ready to give his talk. Thank you so much.
So, thanks, Lisa. Thanks, Garrow, and everybody involved in making this happen. Let me get my screen share going here so we can get things rolling. Let's see this, this, then screen share. Every software uses a different thing to do the screen share thing. Where did this one go? Where did they put the screen share on this thing?
Should be in the middle bottom.
No. Oh.
Or it says mute, stop video, and then share.
Okay, it's I see. I need to enable the preferences because I didn't have a WebEx set up here, so my Mac does not want to let me share
You're gonna
it.
have to leave the call and come back into.
Oh, will I? Let's see.
Probably.
Let's try that. Okay, I'm enabling that. Yes, I'll rejoin in a moment. Let's see.
The joys of using Mac with screen sharing.
Unmute myself. Yeah, the button still shows disabled.
Okay.
Even though I gave the
came back, I'm giving you powers again.
there you go. Special powers. That's what I'm talking about. All right. Share the thingy. All right, and then let me go. Okay, can you guys see my PowerPoint thingy? Excellent. All right, sorry about that. Okay, cool. So welcome everybody. Make sure, let's see, we may have to mute. I think it's your speaker. Good, no problem. Make sure we don't get any weird feedback here. Thanks for joining in the meeting. And to me, it's always a pleasure to speak to the HDNUG. I mean, pretty much since 2004, whenever I'm in town, I have to speak at HDNUG at least once a year. So this is it for this year. Always a pleasure. This is my hometown, right? User group, or it has been for the last, 19 years now. So very cool. I'm Claudio La Sala. You have my email information up there. I always put it up at the beginning of the talk and at the end of the talk, because if you end up thinking of questions that you may have, or concerns or comments you would like to make that you think up later, well, that's my email. You just reach out, and I'm always happy to continue conversations based on the talks that we've had at user groups and conferences. I'm a technical director here with Improving at the Houston office. You see like a copy of my business card there, and you can see I'm like all over the place. I'm not your typical software developer, right? Besides writing software, which we're going to be talking for the next hour and 20 minutes or so, I also have other areas of passion, such as making music, like playing a bunch of instruments, writing my own music, recording them, riding, fast motorcycles at the racetrack, because that's how I keep my cool. That's how I keep my zen. So there's more to life than just writing code, okay? Even though as I start talking about code, you're going to think this guy can only think code. It's not the case at all, right? So check it out. I have a blog, lasala.net, where I write about a bunch of stuff. Many of the things that I'm going to be covering tonight, I've blogged about in some further detail. So keep an eye on that as well. And again, it's not just technical, because for being a consultant, you have to know more than just writing code. It's very important. So check it out. I have previously given a talk on refactoring test code through the Friday talks that we offer at Improving, that's offered for free for the public. If you look up on the Improving Enterprises YouTube channel, you look up for refactoring test code, you're going to see another side of the session that we're going to be seeing today. It's not a prerequisite that you have watched that before joining this one, but later, if you want to further your understanding of this topic, check that talk out as well, because it's going to just give you more tools that you can play with. The quick gist of what that talk is essentially me walking through the process of going from the traditional way that we learn to write unit tests or integration tests, any kind of test really, which is a AAA template: arrange, act, assert, which looks somewhat like what you see on the screen on the left side, and transitioning over to a given when then style, or gherkin, as some people know this format of communication for acceptance criteria and such. The tests on the left are the same as the tests on the right. Now, at least in my mind, the tests on the right read way better. It's easier to understand what is it that we have there that we are verifying. It's easy to use that in conversation with non-technical folks, like your business analysts, your QA folks who are not into automated testing, your product owner, right? And even with other developers. Maybe you have other developers who are not as familiar with the implementation of certain features. If you have tests described in a clean and concise way like this, it's going to make their lives easier as they are trying to learn and contribute to the project. So that's a gist of that talk. Today's talk takes this a step further and just keeps going through reorganizing the tests and applying this mindset to make tests easier to maintain, easier to write, and easier to read, both by technical and non-technical people. So talking about that, and why is that important? Most of the times when you ask developers, hey, why do you write tests, right? And I know the way I used to answer that question is, well, just to make sure that my code works. That was and pretty much every developer's standard response. Why do you write tests? To make sure that my code works. And then followed by, yeah, but I don't write many tests because the business does not let us write tests, because they're not paying us to write tests, and that does not add value to the business. Well, yeah, as long as we are saying we're writing the test to make sure that our code works, what's in it for the business, right? The business is more like, dude, I'm paying you to make sure that your code works. It better works. So I've learned to flip that around and start thinking, okay, hold on. I am not writing tests to make sure that my code works. Instead, I'm writing tests to describe my current understanding of the feature, the acceptance criteria that we are implementing. As I've made that switch and I incorporate the business talk into my tests, I can share my tests with the business and they go like, oh, this guy is actually listening when we are in our sprint planning, because the business things that we are talking, I can see that in their C# code, in their JavaScript and TypeScript code. Yeah, they are listening. So we don't have to justify, oh, I'm spending the time to write tests. No, they start seeing, oh, they are taking the time to describe it in code what the understanding of the business is. Do more of that, right? So I haven't had to justify why I'm writing tests for at least a decade now, right? They bring value to the business and clarity to the developers. How does it bring value to the business? Well, if you are describing the understanding, the team's understanding of the business as tests or as specs, as we rather use, for the business, later on down the road, when you have different developers joining in the project, it's going to make it easier for them to understand the solution and contribute to the solution. So this is you bringing value to the business paying forward, right? That's one aspect to it. The other is adding clarity to developers. When developers go into the code and they look at it, it's like, why is it implemented this way? What does this do? Well, if you take a step back and you have tests that describe not the, I am instantiating a business object, I am saving the data in the database. No, I don't want to see tests that look like that. I want to see tests that say, given I have a product that's in inventory and the user places an order, this is the kind of language that I want to see in my tests. Not the technical stuff, but the actual business language. So having that clarity, it opens up possibilities. Make the tests easier to read, write, and maintain. Because again, after a while, if tests get too cumbersome, developers will abandon them. Been there, done that, right? You go back to some tests, it's like, there are 300 of lines for this test. I have no idea what it's doing. The actual fix for the thing, it will take me 2 lines. I'm going to make those changes, commit, and call it a day. Forget about the tests. We've all been there, right? I don't want that. I want people to be able to read the test and say, oh yeah, I see what's happening, right? I need to make a change. Okay, it's easy to make a change. So I'll change the test to accommodate the defects or the feature that we are bringing on. And then I'm going to make a change to the implementation. I want to make that easy. I need to write new tests. I want to make it so that it's easy to write new tests. If people say, oh, I'm not writing a test for this new feature because it's hard. Why is it hard? Right? You have to prove to me, why is it hard? Oh, because it's too cumbersome because of the framework that we're using, or the acceptance criteria is not clear enough, or blah, blah, blah. There's always a reason. And it's always something that we can work on. Oh, the acceptance criteria is not clear? Well, let's fix that first, right? Because if the acceptance criteria is not clear, if you cannot find good English to describe the criteria, you're not going to find good C# or JavaScript or whatever programming language to describe the thing if you cannot use English to describe the thing that you're trying to build. So let's start there, right? Very important. The more people will buy in. So if you flip things around, you get closer to the non-technical folks, they will buy into your praxis. They're going to ask you, why are you not writing those tests thing that you normally do, right? They become your advocate, as opposed to you having to justify, well, we write tests because as a byproduct of tests, if we break something, it will fail the build, and then it becomes cheaper to fix. Ugh, it's too technical, and it shouldn't be like, that's a nice byproduct of tests. If you mess things up, they'll tell you. But going way beyond that is, how do you understand what you currently have implemented so that you can feel comfortable with making changes? Because we read and change code way more than we write code. Writing code is cheap. Reading code to a point where we feel confident that we can make changes to it, that is expensive. Because you spend like how long trying to figure out, what is this thing doing? Why is it doing this way? And then hours later, like, okay, now I think if I change this line of code, right? So if you can decrease that timeline between facing code and feeling like you can actually make changes to it deliberately, it's like, okay, this is what I need to change, the better, right? The tech stack that we're going to be looking at here, it's going to be tests written in C#, just because I had to pick one language. But I follow the same approach, regardless of language, regardless of testing framework, testing runner, tech stack, it does not matter. The practice that I'm going to be showing here, like context-based testing, I've been following for at least 13 years, right? I remember that I gave a talk on it like in 2008, and that was already in C#, but after that, I've been through JavaScript, TypeScript, Ruby, I've used MS Test, NUnit, XUnit, Jest, Jasmine, Cypress, unit test, integration test, end-to-end test, front-end, back-end. Anywhere where I'm writing tests or specs, if you will, I follow the exact same pattern. So the same things that I'm going to be showing here that I do in C#, I'll bend whatever language to give me what I need. So like when traditional Cypress folks look at the code that I write, they're like, oh, I didn't know that you could do that. So like, yeah, because I'm writing my automated tests from a developer's standpoint, and as a software developer who understands clean code, solid principles, design patterns, I apply those to my test code as well, as opposed to just saying, oh, that's just test code. It doesn't matter. No, it does. If you use it with this intent of describing what you're building, right? The business implementation of what you're trying to accomplish here. All right, very cool. So for Q&A, since we have a hybrid setup, folks in the room, just raise your hand whenever you have a question. Folks who are online, I have only one screen, so it's going to be hard for me to see if there's anything in the chat. So you guys here in the room, let me know if questions come up. I'll take them as we go. If I'm like right in the middle of something, I need to finish my thought before I take the question, but I'll make sure that I take as many questions as I can. If we end up running out of time and don't have enough time to cover all the questions, I'll take them offline and get back to you. Let's get right into it. Just one quick disclaimer. The sample that I'm going to be sharing here, the domain, is in the banking industry. Now, I have never worked at a bank. My understanding of banks and bank accounts and withdrawing and depositing is from a user of those services, a client of a bank. So if there's if anybody here in the call that works in the financial industry and may say, that's not how we do it, like, thank you. Later, let me know a better way to represent that. Just a quick disclaimer. All right, good. So the way I do this, I'm going to go through a series of screenshots where I can highlight the parts of the code that I need you to focus on, right? And that way we can get things flowing here and take it from there. So normally, a pattern that pretty much every developer follows when writing tests is to write one test fixture, meaning one test file per thing that we are testing, like per class or per component or per whatever big thing it is that you are testing. So you end up having a test file that may have, easily 3,000 lines of code, right? Because if you're writing tests for a class, the class itself has 1,000 lines of code. That if you do have that, that's already a problem, right? But still, folks will write tests for that one long class, and guess what? The test file is going to be humongous. It's going to be one of those that people will just abandon because it gets too convoluted. And they may look somewhat like what we have on the screen here. So let's pretend that we have a bank account class, right? So a class that represents a bank account. And usually what we do is name the file, the thing that you're testing, and then tests or specs, right? So bank account tests, and then dump all of the tests for that class into this file. So like in this case, we have withdraw valid amount, deposit negative amount. And then you have your typical, even though I don't have the / arrange act assert, you can kind of see arrange act assert, right? And then the next one, arrange act assert. Problem with this is that I had to make the sample small enough so that it could fit on the screen like this. In the real world, most tests will be way longer than that because your arrange part ends up being like 10, 20, 50 lines of code with mocking of a bunch of stuff, like mock this, mock that, create a stub for this, and return the stub in this mock. And then you have like all of this setup. You don't even know what you're setting up anymore. You don't know why for this mock you're returning a true. It's like, what does it mean to return a true when this thing gets called by the innards of the implementation of the thing that I'm testing? That all gets lost, right? And what happens is, oh, now I need to write a new test for this class. What do? Copy one of the tests that looks somewhat like what you need to reproduce, paste it, change a true for a false here, replace a 1 with a 2 here, a string here and there, and go to town. And that thing just keeps carrying over. In every single line of code, it will get copied and pasted at some point or another. That's just a fact. So that's something that I always keep in mind. It's like, okay, I'm writing this code here. I'm sure somebody's going to copy and paste this. If they do, will I feel guilty about it? Will I feel like, oh, I'm going to need to take a shower after that because I feel dirty, right? That's like, it's the way I live by when I'm working with code. It's like, am I comfortable with the thing that I have in front of me right now? Sometimes I'm not. And if I don't know how to make it any better, or maybe I don't have the time to do so, I'll drop a to-do comment there saying, whoever looks at this later, it might be yourself, Claudio. This is, what we could do at this point in time, right? But it's a note for me to later come back around and say, now I know how to make this better, right? Or for somebody to look at that and say, oh, I saw your message there, your to-do comment. I'll show you how to make it better. Oh, thank you, right? So I want to apply the same concept to tests because people will copy and paste the tests as they are there, right? So in a test file like that, when you collapse all the tests, you're going to end up sometimes with hundreds. I've seen thousands of tests for a given class or components, right? And that's the problem, right? Another or one approach that like folks in the C# land will use is the feature of regions, right? Where you can wrap a group of methods, in this case, in regions that you can then collapse. And then you can see all my tests for deposit, all my tests for withdrawing, all of my tests for, it's still disgusting, right? Folks who have seen me talk about like regions in C#, they know it's like, oh, here he comes talking about regions. Yeah, they suck, right? They just suck. Don't use it. If you're using them, there are better ways to do it. So what I like doing is the following. Instead of organizing tests like this, what about creating one test file per, like in this case, per method on the class that we're testing, right? So we used to have, on the previous screen, we had one test file named bank account tests with all of these tests. And then we have some logical grouping here: deposit, withdraw, transfer funds. All right, let's recognize that. And let's instead create a folder for the bank accounts. And then notice that I've named specs. Let's start thinking of them not as tests, but as specification of the feature that the thing provides. And then in there, I have one file per logical grouping: deposit, transfer funds, withdraw. And then we pull those methods in here. It's like, it's the first step. So instead of one file with hundreds of methods, you have separate files with the specific things that you're looking for. This is the first step. the way I normally start refactoring some of these tests. In some of those previous examples, we saw that, for example, here, the setup looks similar in both of the tests that we can see. And if we scroll through all the tests, they all look the same. They all instantiate bank accounts. Some may pass a parameter, others may not pass a parameter. But the instantiation of the bank account happens on every single test. That is redundant code. That in implementation code, we normally look for redundancies and we extract those redundant pieces of code into separate things that we can reuse. Why don't we do the same in tests? So when I have something like that, I start extracting like the instantiation of the bank account. I extract that into a separate method. I name it given the thing that I'm expected to use here, like given bank accounts or given a bank account, right? And call that method from here. Because now, of course, you can use given bank account here, and then here, and on all of the other tests that we have for that feature. Why is that a thing that we should take into account? Well, right now, this is how we instantiate a bank account. What if later on we decide, you know, we would like to change the way we create bank account instances, and maybe we want to switch from, instead of using a public constructor, we want to create a factory method on that class. Or maybe we want to create a factory class altogether. Well, now guess what? You're going to have to go through all of your tests and update them. Well, if you have one method that you use to create an instance of the thing that you're testing, you have one place that you have to go and fix, right? It goes back to the whole, what is refactoring? Well, refactoring is the process that you follow to improve the internal implementation of something without changing the external behavior, right? So if whenever you decide that you want to improve the internal implementation of something, and then you have to come and change the tests, is that really refactoring? Because now you shouldn't have to change the tests if you're just trying to change the implementation of the thing, right? Taking that another step, notice that I did the same with the call into the method that we're trying to test. So instead of having, like here, we have a call to deposit here, which because of the whole should throw a certain expression, we have to wrap that in a lambda, in a delegate, call that, because that's going to wrap in a try catch and look for that specific exception. And then down here, we're just calling the method directly. So every time we call that method, that is redundant code. Because again, if you want to change the signature of that method, now you have multiple places where you want to go and change. Of course, yeah, you can use some tools like a ReSharper or other plugins to help you rename things. But still, it could be a rename that's going to touch multiple test files when it could be just one or two. Notice that's what I did here was to take that the actual action that we are trying to test, and I pulled it at the top of the file. So essentially, as I'm learning the system and I want to see, hey, how do we make deposits? Well, we have an account thing that has a deposit method that takes in an amount, right? And then you can hover over amount and see whether it's a decimal, an integer, or a money type, whatever. But you see, like right there, this is documentation of your system. Right at the top, this is how we make deposits. Account, deposit, amount, right? And then, okay, when trying to deposit -10, when depositing 10, okay, how is that implemented? Well, that's just simply invoking that action, right? So I store that action as a delegate up there. Down here, I just call it. Yes, it's a delegate. I could just say deposit action, open close parentheses, but I rather call invoke just to make it very clear that this is not just a function in the class. It's a delegate that we are calling, right? So it makes it clearer for the reader. And the other stuff. Sometimes people say, well, but in C#, don't we normally put the fields up at the top? Yeah, in implementation code, oftentimes we do that, but here I'm using C# not to implement what goes in production, but to describe our system. So I'm bending what I'm using C# for. So what I do is when I open my spec files, I want to see those given when thens all the way at the top. Those are the most important things when I'm trying to learn what is this system about. Open the test, look at the top. It's going to tell you. Then you want to see the details. You just keep scrolling down the file. You're going to see all the details you need, right? But all the fields, and if they are fields or properties, it doesn't matter. It's an implementation detail for those specs. Moving on here, the last bit, the assertion part, right? So the then it throws this is exception. Then the new account balance should be this amount, right? That's just hiding those details, right? Those assertions. Why does it matter hiding those things? Again, yeah, I could have a non-technical person read this. Account balance should equal expected balance. But I rather read it like this. Then the new account balance should be this. Because also, if I'm reading this, I'm exposing, for example, the fact that I have an object with a balance property, which for the non-technical person is like, what is a property, right? What is a field, right? If later you want to change the way you've modeled balances so that instead of having like a decimal property, you have a function that returns a composite object that represents a bunch of stuff about balance, you would only need to change this one helper then method, as opposed to going through all of your tests that are directly accessing balance and make changes there to accommodate for that change, right? So that protects you against future changes, or lets you, not against, but it lets you embrace future changes without thinking, how many files you're going to touch or what kind of impact it's going to have. All right. Then what do we have here? Oh, yeah, we were looking at that. Good, good, good. All right, another file in that split that I did. So another method that we had tests for is a transfer funds to, right? So again, at the top, we have the action that represents the feature that we are trying to access. In this case, transferring funds to from one account to another. So source account, transfer funds to destination account, and what is the amount. Very clear as a way to document your API into the feature. Right, following that right along, we have, okay, here we are representing a valid transfer. So it's like a happy path transfer. Everything is good. The accounts have the balance and they are all in good standing, so we can perform this operation. Look at how the code reads. Given source account with balance of 100, given destination account with balance of 50, when transferring 40, then balancing source account should be 60, then balancing destination account should be 90, right? Any person who reads English should be able to follow this. Doesn't have to be a C# developer. It doesn't have to be a TypeScript developer. It doesn't have to be a technical person. Anybody who can read English can read this. What's the advantage of that? You can collaborate with your business analyst. You can collaborate with your product owner by looking at code. You're looking at code here. It looks funny with the underscores, but it's very easy for people to just abstract the underscores out of the way and read the sentences. Notice that I'm not using any special library for this, because a lot of times what we're looking at here is BDD, behavior-driven development, right? This is the gist of it. Many times when people talk about BDD, they start talking about, oh, but then there are tools and I have to set up CI/CD pipelines and I need to automate this. And it's like, no, dude. I do BDD with a napkin and a pen and with two people having a conversation. That's how BDD starts, right? If it requires special tooling, we're not doing the thing the way we're supposed to, right? When I first started with this, I used to use some like crazy exotic C# frameworks for BDD that I had to spend a lot of time coaching people into using the syntax of those tools. And then people would not write tests because they couldn't get their mind around the framework, the tooling. I took a step back and I said, no. If you can write C# code, this is just plain vanilla C#. You're just creating a class that has methods on it. Oh, but what about these methods with the underscore? It's like, yes, the way I say it, the same way I'm here speaking English with a Brazilian accent, you guys can still get my message. We can still communicate. Here, you're looking at C# with a Ruby accent, right? So I picked up the whole everything lowercase underscores in Ruby because really, it makes it a lot easier to read. Imagine these sentences if they were written following the C# design guidelines, where it's everything Pascal case, everything jumbled together, kind of hard to see the word boundaries. What for? Purpose of the code that we're looking at is to describe our understanding of the system, not to satisfy the C# design guidelines. The production code, implementation code, yes, go full-blown C# design guidelines. Describing specs, just do whatever it takes to make it easy for people to read it, period. Okay? So no special tools, no special understanding of the language. It's just creating methods. As long as you know how to create a method in the whatever tool you're using, you should be able to create tests like this. Notice that the instantiation of the account, here I also took another step, and instead of instantiating the account directly, I created another helper little function here, or method, make account with initial balance. So I abstracted that out, so that when I'm maintaining the test, again, at this point, I don't want to see exactly how we instantiate accounts. I just want to know that that's what we are doing. Oh, we're creating a new account for the source account. We're creating a new account for the destination account. I don't want to see the details of the instantiation of that class yet. If I do, click on the thing, F12, it will take you there, right? So you go on demand. You explore things on demand. Looking at the final set of tests for that sample case, notice the withdraw. Same thing, like look how succinct the tests are. Withdraw valid amount. So at the top, account withdraw amount. Valid amount, given account with 50, when withdrawn 10, then the balance should reflect withdraw $40. Withdraw negative amount, when trying to withdraw -10, then it throws an exception. Withdraw overdraft, so you had $50 on the account, you try to withdraw 80, it throws a big fat exception, right? Very easy to follow along what test cases, what scenarios we are actually supporting in our app, right? Notice another step that I've taken, since these are all tests related to bank accounts, I've extracted some of that functionality into a base class called bank account base. And that's where I instantiate the bank account, or where I instantiate the bank account with an initial balance, or with an initial balance and a line of credit. By abstracting that out here, again, as I'm learning the system, if I need to know how do we work with bank accounts, there is one file here that shows me how that class could possibly be instantiated, or how was it designed, right? What was the design process that we've gone through to support, in this case, instantiating this class? If in the future we decide, as I mentioned before, instead of instantiating the class by using its constructors, now we're going to start using factories. Okay, no big deal. You come here into one file and you make those changes here. You don't have to touch the other specs for your feature, right? Good deal? All right, cool. Any questions so far? Sorry, that way I can take a sip. All good? All right, anything in the chat window there? Nope, all right.
Set up or you're given statements.
Mhm.
Want to one is given, but I also want to tweak it. Or
Yes.
did you create a new method? Call the original method and then
much like here, let's say, so like here, I'm like, is that what you're asking? Like parameterizing the given?
Yeah. Yeah. For example, you want account with 500 and a pending transaction. So if you want to do that, you can follow the same method that you already created. They add the extra information, or you new method.
Yes. I really let it drive by, like, I don't have a hard and fast rule. I would go with whatever makes a test easier to read, right? So sometimes it means I create one given method that does the one thing and the second one for the other thing. Sometimes I combine the two. If that will improve readability of the spec, I will go with it, right? My main goal is, can I make it easy to read? And then can I make it easy to reuse so that I can write other tests without having to write a whole bunch of new lines of code? Okay? All right.
It's like in actual practice, how this is the test refactoring has changed drastically.
So when features change drastically, it can get really messy if you don't follow a practice like this, right? Because now if you have the pattern of one test fixture per class and you have hundreds of tests there, and then the feature, changes drastically, you're going to have to go through all of those tests and change them. If you organize them in a manner that I'm showing here, it's going to get you much closer to the desired results. Now, I have to say the following. For features to drastically change, there are two reasons that I can think of that might happen. One is the business got it all wrong when they first asked you to build the feature. It's like, okay, we asked you guys to build this thing. It was our completely wrong interpretation of our industry. We're going to have to redo it because what we have has nothing to do with what we really need. It might happen, right? The other situation is people gave not enough thought in conversation and collaboration when the feature was being discussed, right? So maybe the people who wrote the feature, the user story, or however you're doing requirements, gave or did a poor job at describing the feature, gave that to the developer said, don't worry about it. I got it, right? And then the developer spends like 4 sprints, almost done. Okay, now we're done. And then present that to the stakeholders. Stakeholders are like, no, we cannot use that. That's not at all what we need. Back to the drawing board. So now you have something implemented and you're going to have drastic changes because the interpretation of the feature as per the developer was completely wrong. It had nothing to do with what the business needs. That's why I say, if between developers and the stakeholders, they cannot have a clear conversation in English and everybody's like nodding their head saying, yes, we are all on board. We understand completely not what we need to build, but why do we need to build it? So the case that I always bring up to stakeholders is, if I see a user story that says, I want the delete button on screen X, Y, and Z, I'll say, no, you don't. You do not want a delete button. Well, what do you mean? If I don't need that product anymore, I should be able to delete it. No. Have you sold that product before? Yes. Like, okay, if you delete that product, it's not going to show up on your accounting reports. Oh, no, I meant a soft delete. Like, no, that's a technical thing as far as like, do we want to completely destroy any evidence that you have of that data? Or do you want to just not provide it, make it available so that people don't buy that product anymore? Yeah, that. It's like, yeah, you want to discontinue the product. There's an English word for that. It's not delete, it's discontinue, right? Example that I always also give people. We call a pizza place, for example. Yeah, I'm that old when we used to call to order pizza, right? And then you place your order. 30 minutes later, you're like, oh, I don't feel like eating pizza anymore. Do you call the pizza place and say, yes, I would like to delete my order? Who talks like that? Right? You don't delete orders. You don't delete employees, right? You cancel orders. You put orders on hold. You fire employees, right? There is a business term, or at the very least, an English word that represents that. So let's have those conversations. If somebody asks you to add a delete button somewhere, don't just do it, because you may have to go back and drastically change a feature because people said, oh no, we deleted that data, now we cannot go back and have historical records. Yeah, because we didn't have the conversation. So if you do take the time, and I know that that's hard for developers to do because developers want to write code. Don't. If you cannot describe in English what you're going to be building, you shouldn't be writing any code, right? Because chances are you're going to implement the wrong thing. You're going to present that to the business will fire it right back at you, and then you're going to have to drastically change the implementation. Well, it's not really a drastic change to the implementation. It's just that you didn't understand the thing to begin with. That's why you're having to change it, right? So I hope that answers the question. If not, drop another note. I'll keep moving, and then we can revisit some of these aspects here. So we looked at those tests. Remember what was my next point here. Hold on. So we were looking at withdraw. We saw all of those methods. Oh, gotcha. All right. So up to this point, we took that first step, which was create a folder for the class or component that you're testing, create a file per feature that class gives you, which would map to a method on that class, right? Now, the next step is the following. When we look at like withdraw, well, withdraw is kind of like an overloaded thing because we can test, or we should test, withdraw valid amount, withdraw negative amount, withdraw when there's an overdraft, withdraw outside the line of credit, within line of credit, withdraw on an account that has been flagged as fraud, as a fraudulent account. So there's a lot more to withdrawing than just taking the money out of the account. As we are seeing here, right? Now the tests are showing us all those things. Maybe we should split those into separate files as well. So that's usually my next step. What do I see here? Like overdraft is a separate context here. Line of credit is another one. Fraud is another one. So what do? I create one folder per feature. Notice that I keep saying feature, not per method. Because currently, yeah, we have a method to make deposits, a method to transfer funds, and a method to withdraw things. Today is a method. Tomorrow, it may be an aggregate of classes and services that will provide you those features. So that I don't want to tie my specs to the current implementation. It would be a method on a class. I want to tie my specs to the features that I'm building. So notice that instead of saying deposit, transfer funds to, withdraw, I'm naming it after the verb, right? Depositing, transferring funds, withdrawing. Because there I'm describing the business feature that we're offering, not the actual implementation. Okay, that's a very important concept, and notice that I started making those changes here as well. So now we look at depositing. Notice that I've created a depositing context, because for all the specs around depositing, there will be things that will be reused across those tests. So I recognize that in a depositing context-based class, right? I started with underscore, so it shows at the top of that folder. Again, if somebody's joining the project and want to see, oh, so when we're doing banking and we're depositing, what about it, right? Well, start at that file. That will tell you, for example, well, this is how we do deposits, right? There is a method currently in a class that takes in the deposit amount. Okay, cool. That's where you start, and then you start looking at the different cases that we support, like invalid amount, valid amount, and so on. And of course, all of these, like the whens, the thens, those are shared across the other spec files. So you don't have to recreate the wheel every time. You protect the method and the signature of that method, the current API into that feature, and you protect how you're validating those things. Like, as I said, today we have a balanced property. Tomorrow we may have something else where we are going to go and ask this object for that information. Well, if that changes, I change it only here, but not on my spec itself. The spec would still say, then the balance should be this. How you're going to be getting that balance, I don't care. Right? So that's a part of, you're changing the internal implementation, but not the external behavior. Make sense? All right. Good deal. Moving along. So like, once we get to this, notice the test for depositing. Now we have two files, one for invalid amount, one for valid amount. I'm showing them side by side. So that's how big I like seeing my tests, right? Like pretty small like that. I have like 1, 2, 3 tests at the most per class because I keep them very granular like that, which also answers when people see me like using fields in a test class to hold state. People say, well, but then if you're running those tests in parallel, would that not cause problems for you because you have two processes trying to access the same field, and now this test has that property or that field at 10. Now this one is verifying at 5, and now test fails. Like, no, I don't have that problem. First, because I set my test runner to not run tests in parallel in the same file, right? Second, oh, but that's not like a performance issue. Well, no, because I only have like 1 or 2 or 3 tests per file. So, and they are unit tests, so they run like this, right? So tests in separate files, they run in parallel, not within the same file. If I had 100 tests in the same file, that would be a problem. I don't have 100 tests in the same file, right? Cool. If we look at the other ones, same deal. Like withdrawing, there is a withdrawing context at the top, and then this is how currently we implement or we give access into the withdraw feature. Account withdraw amount, right? We instantiate the account, right? We use a method from the base class for bank accounts, right? Give account with, make account with initial balance. Give an account with this thing and that thing, right? So all very small, simple to use methods that we can reuse every place else. Looking at some of those tests, like withdrawing line of credit, okay? Inherits from withdrawing context because we always use the same method here. Look how it reads. Withdraw outside line of credit. Give an account with initial balance of 50 and line of credit of 100. When trying to withdraw 200, then it throws an invalid amount exception. Pretty easy to read. Withdraw within line of credit. Give an account with initial balance of 50, line of credit of 100. When withdrawing 80, then the new account balance should be 0, right? Because you had 50, you took out 80. Then the new line of credit balance should be 70, right? Because you've used 30 bucks from that 100 that you had there. Or yeah, right? So pretty easy to follow along. Notice that like a rider, JetBrains rider here is telling me, hey, initial balance, line of credit, you don't have to use those parameter names. You could remove it, but I keep it because it allows me to read in English. Give an account with initial balance of 50, line of credit 100. Right? So I always favor, how does it read? I look at the test, the spec, and say, how does it read? Does it make sense? If somebody is non-technical, like, and this is a practice that I follow. I write these tests. Before I actually implement them, I share them with my business analyst, with my product owner, with my QA person. And I say, hey, does this test actually describe the thing that we're building? And sometimes they're going to go like, oh, no, this is not how our line of credit works. Okay, let's talk about it. Before I go into the weeds and actually write the C# code or the JavaScript or whatever, to implement that. Let's talk about this first, right? So the chances that, by the time I finish the feature, somebody's going to come back and say, oh, that feature has drastically changed. You're going to have to change everything. You diminish that chance because we've had these conversations before we actually write the code, right? So it's not a hassle making changes later. All right, good. Look at that. So this would be an approach, say, to create a new feature, right? So up to this point, I started from one test fixture that had a bunch of tests, and I started refactoring. And this is my step, right? Start creating the separate files, start pulling things into the separate files. Look what's common between them. Usually, like the setup is very common. Like the way you're setting your mocks for one group of tests is very similar. So we want to recognize, why is it that they are similar? Oh, because they represent a case where we do have a product available in stock. That's a context. Recognize that those tests belong in a separate file, right? If not in separate files later, right? So I start like extracting those. This is abstraction at its best, right? You abstract, you put together the things that should go together that are likely to change together. That includes tests, not just implementation code, right? Recognize that, take those steps, and start fine-tuning. Sometimes this is all it takes. This is how far I go. But sometimes, let's say that's maybe the things in the business about, say, overdraft handling changes such that it gets way more complex. And now the tests that we have within overdraft amount, now we have like a dozen tests in there. Guess what do I do? Create a line of credit folder and split those tests into a subfolder. I'm gonna go granular like that. Now, if I start going too granular, it might indicate a problem with either the implementation of the feature, right? Where you have a feature where the implementation is doing way too much. Maybe it should be split into different things. Or the service or the thing that the business is offering is complicated, right? So again, it allows you to have a conversation with the business and say, hey, the way we're doing withdrawing, the overdraft handling, that's getting kind of complex. Our clients, are they understanding that actually? So it enables developers to have this kind of meaningful conversation with the business for things that maybe the business is not even aware of those things. But then we developers, we go back to them and say, hey, are you guys aware of these things? Yeah, no wonder our clients are having a hard time using this feature. It's because it's kind of bloated. It's kind of, all right, let's have more of these conversations. Let's shift things around as we learn and as the business grows, right, organically. So once I've made those kind of refactorings and reorganized my tests into context, new features, I will start from that premise. And by the way, if I'm starting a brand new feature that didn't have any tests to begin with, I would start from my organization into maybe folders based on the scenarios. I'll play it based on what is it that I'm learning from the feature. So say that after all of this, it's all working, all happy in production, the client says, oh, now we have to support a new feature. It's a new service that we are allowing to our clients where we are controlling the daily limit for withdrawals because people are getting robbed and, you know, the thieves will get their debit cards and go to the bank and withdraw like whatever, however much money they have there. So we want to put a limit there. Oh, it's a new. Think about this discussion. It's not about the business just saying you have to limit the amount. It's like, why do we need to limit the amount? Oh, because there is a problem. It's a social problem here where people are getting robbed and we need to control. Oh, okay. That's how we are providing value to our stakeholders, to our clients, right? It's a different kind of conversation that developers have with the business. And they do appreciate that. They will trust you more if as the people who write code, you can also have this kind of conversation with them. So we say, all right, so let's create a new spec for the daily limit feature. Now, tell me about it, right? Let's talk about this feature. So they say, well, maybe somebody's trying to withdraw an amount that's above the daily limit or within the daily limit. Okay, those are the two cases that we're considering at the moment. All right, tell me more about it. Let's describe those scenarios a little bit deeper. And then we end up writing the following. Amount above the daily limit. Also, notice how I play with casing on the names, and that's deliberate. It's to draw the reader's attention. Because if I come in here and say, okay, bank accounts, withdrawing, daily limit. Okay, above, within, right? It draws your attention to that. That's what's different between the two tests. One is verifying above, the other one within limits, right? Makes it easier for people to follow along. Okay, what's different between those two? The first one, give an account with initial balance of 500, daily limit of 100. When withdrawing 40, then new account balance should be 460. When trying to withdraw 80, then it throws withdraw amount exceeds daily limit exception. Notice that here, it's like, okay, how do we specify the daily limit on an account? I don't know. I'm not there yet, right? I'm thinking of the service, the thing that we're offering our customers. We're offering a daily limit on the account. So let's describe it here first without thinking about the implementation. We're saying, well, we want to throw an exception that represents the thing. Okay, withdraw amount exceeds daily limit exception. It's going to be what we're going to throw and handle somewhere. It's showing in red because we don't have that yet. Oh, isn't that what TDD is? Yes. So when people ask, what's the difference between TDD and BDD? Aren't they the same thing? Like, no, they go hand in hand. So when we're doing the give and when thens, we are doing behavior-driven design, right? So we are saying, this is the behavior we are planning to implement. Given this, when this thing, then this other thing. As we start thinking about, all right, are we going to be throwing exceptions? What is the name of that exception? Are we going to create new objects, new properties, methods? What? This is TDD, right? So one goes hand in hand with the other. The bottom, amount within daily limit. How do we represent that? Give an account with initial balance of 500, daily limit of 100. When withdrawing 100 yesterday, then the new account balance should be 400. When withdrawing 100 today, then the new account should be balance should be 300. Like, oh, what is yesterday? What is today? Well, I don't know. It's just how I want to represent this test. This is how I want to read this test, right? Well, but what is yesterday? We'll get there because we could have put like some arbitrary date in there that represents a date in the past. And then another one, you would never be able to represent today if you put a date in there because it's going to change every day, right? So, and the way people would normally say is like, if you're talking to the BA, they might say, well, imagine this, you withdraw money yesterday, and then you go there today. That's how they're talking. Let's try to incorporate that into how we're describing the problem here, right? That's what we're doing. So then how do we implement that? Right there, yesterday, today, those are just properties, right? And well, how do we represent yesterday? Well, date time now, add a negative day, right? It's going to create date time now, and it's going to subtract one day. It's going to be yesterday. There you go, right? Nothing special about it. And today is just date time.now, right? Very easy. It's a very simple trick to be able to write your tests in a manner that read, it's readable. It uses your language, like whatever language you're using, you should be able to pull off, little tricks like that. So we represented the feature. Again, so far, I have not implemented any line of code. I'm just describing the problem. Every single problem, the most important thing for you is to be able to accurately describe the problem. If you cannot describe the problem, you cannot solve it, right? Otherwise, as we were joking before, it's like, hey, the test is passing. I have no idea why. Like, well, yeah, you didn't understand the problem to begin with, right? That's most likely the case. So make sure you can describe the problem you're trying to solve. So this, once we get to an agreement where it's like, yep, this is exactly what we're trying to offer to our clients. The people paying the money, that's, enabling us to actually work on the project. Okay, next step, we do it very similar to the other things we had before, like then it throws whatever exception. Now, something we have to do when we deal with dates, right? We have to be able to control what is date.now or datetime.now because it changes every day. So you have to control that. Well, we don't have the datetime.now class because that's a .NET thing. We don't own that. So what we normally do, there's a pattern called the static gateway pattern, right? Where essentially you implement a singleton pattern where you can swap that instance. Right? So here, it's implemented like this. There is a clock class that I've created that I say, okay, I'm going to set a now getter. So whenever my code is trying to get now, this is what I want it to return. And then I just say, hey, whenever you're trying to figure out what now is, here's the date. Remember we said when withdrawing yesterday, okay, what is yesterday? Because when the code says datetime.now or the equivalent, it has to be yesterday's date because I cannot go back in time, but you can control it like that. And then when it comes time to implementing that, that's just a static class. It's a clock. It has a function that's our now getter, right? By default, it uses the .NET datetime.now. That's just a default. But you can override that behavior here, which comes in handy in testing cases, right? Where you want to control what that's now is going to return, okay? So just dropping the static gateway there, because it's a very useful pattern that I've been using over the years. What else here? The implementation of this feature is something like, anytime there's a withdrawal, we just log the amount being withdrawn, and we say, hey, withdraws, add clock.now. So track when the guy is withdrawing, what amount, so that we can, figure out, is it within the daily limit or not? I mean, this is just a sample implementation, really. And finally, another sample feature, right? The user says, or the stakeholders say, the transferring funds, currently, our implementation only allows for transfers, funds to be transferred from one account to another. Clients are happy, but now they are demanding more. They would like to transfer from a set of accounts into one destination account. For example, the person has 4 checking accounts, and every month they want to transfer, from all those accounts into one savings account. It's just a new service that people have been asking, and we want to implement that. Okay, let's look into it. Let's describe that feature. So transferring funds, that's where it lives. We already have something similar to that. So let's put the new test in there. Name it like the context is multiple accounts. All right, let's describe that. We're talking about even distribution. So this is the thing. They want to say, hey, I want to transfer $150 split evenly across all of my accounts. Okay, so let's talk about it. Given checking accounts with balances of 100, 500, and 800, so 3 accounts. Given savings account with a balance of 0, maybe it's a brand new savings account. When transferring to savings account total amount of 150, then checking accounts should have balance of 50, right? 100 minus 50, because that's the spread, 450 and 750, right? So going from this to this. And then the savings account should have a balance of 150. So it's like, hey, business person, does this describe what we are trying to offer here? Yeah, that's exactly what we want to do. All right, good. Notice all the methods are red because I haven't implemented them, right? I'm just typing it all there. And if I had that in text in my Azure board as part of a user story and acceptance criteria, I would just copy from there and paste it here. In fact, I use like a little website that I dump text like that, and then it adds the underscores in the spaces, and I can dump it straight into my code, right? So we get that in place. Excellent. We start creating the placeholders for those for the implementation of those steps, right? And we have something like this. Usually that's my first commit to the feature branch. If we're doing feature branch, right? I picked up a story from the board. I write my specs like this, right? I push it because I started working on that feature. I push it up and I ask for a code review, right? I ask another developer to do a code review. I ask the QA person to do a code review. Why? Right? Well, maybe the other developer is pairing up with me to implement the actual feature. The QA person is the person that once I'm done with the feature, they're going to do like maybe some manual testing. So if I can get them involved day one into the sprint, you don't have that situation where developers work on a feature for 8 days, and then the day before the end of the sprint, we turn it over to QA and say, here, have fun, I'm out. Like, no, if we do this, devs, the coders, and the testers are collaborating from day one, even before any code has been written. So there's no like, surprise, this is how it works. Like, no, we've been talking about it. It's like the Subway model, right? You walk into Subway and you say, hey, I want a sub with this kind of meat, with this kind of cheese, with this kind of lettuce and tomatoes and all. By the time you get that sandwich, it's going to be pretty much what you've ordered because you've been following along the whole process. Same thing as you're building a feature here. There's no surprise, right? Same thing with the PO, right? You write a test like this, you share it with the BO, the BA or the PO. At the end of the sprint, guess what they're gonna get? Exactly what they asked for, which is one of the things that POs say, yeah, sometimes I do not get from my devs what I've asked for. If you follow this, you are gonna give them what they've asked for, right? Good deal. All right, from there, just implementing the individual steps. Like, okay, given checking accounts with balance of, how am I verifying that? Just, I'm taking in the balances. I do a projection out of that to instantiate my bank accounts. And here I could actually have used my little helper function to instantiate my bank account. Forgot to do that. But you could have implemented this like with a for loop, with a for each. I just like to be as succinct as possible. Also, notice the use of params here. This is something I use a lot, and it's funny. It's something that's been in C# since version 1. Not a lot of devs use, but what it gives us is the ability to send this. Instead of sending like an array of decimals in this case, you just send like one parameter after the other, right? Because you're saying, hey, we're going to get an array of decimals, but let's send it as params. So it reads like, if I had to send like an array, I would have to say new square brackets and then the values. Well, here you don't have to do the new square brackets. So any syntax I can remove from the code to facilitate reading, I'll go for it, right? And using params like that, I use in tests like this a lot. We looked at those, okay, and then when transferring to savings account, total amount of blah. Okay, I'm gonna need a multi-transfer or multi-account transfer action of some sort. I don't know yet what that is, right? In my test, I'm just representing that. I'm gonna need to execute something that will give me that feature. I don't know what that something is yet. I'm just feeling like one step at a time, 1 or 2 or 3 lines of code at a time, right? It's not as overwhelming as, oh, I don't know what to do. Well, you do. Just follow the little steps that you've outlined, right? Put that in place down here. Then checking accounts should have balances of the same trick with the params. And, go to the checking accounts, select the balance out of them, turn them into an array, and compare to what you're receiving. That's it, right? Pretty simple. later we change the way we check balances, we have one way to go change that. Why have I pulled here? Hold on. This is oh, I remember. All right. So now we have to think about, okay, how do we do the actual transferring of funds from one account to another? Remember that the object was designed initially with one transfer funds to method. So it goes from one account to another. Now we have to go from several to one. So we look at our bank account, it has transfer funds too. Well, that's not going to cut it, right? Oh yeah, you can just create a for loop and go through all those accounts. And it's like, well, yeah, from the outside, but I would like to create an API that I can call and say, hey, here are the accounts, the origin accounts, the source accounts. Here's the destination one. Just do the math, right? And provide an API for that. This one is not it, right? We're not going to be able to do it that way. So then I went back to my spec and I said, okay, let me model that multi-transfer action thing. What if I create, for instance, a transfer service class or a transfer process, transfer workflow, whatever. I'm making up the name here. And what if that class has a transfer with even distribution of amount from a list of checking accounts into a savings account? This is TDD, right? So I went from BDD, describing the feature, to TDD. Now I'm thinking, okay, how am I going to implement the behavior described by BDD? Go into TDD and design the API that you would like to have by the time you're done. So I looked at this like, okay, yeah, let's go that way, right? And that's how I ended up implementing, creating a little service that takes those parameters, right? I go and I figure out what is the even distribution of that amount, go through my source accounts, withdraw from the source account, deposit on the other account, right? Take money from one, deposit into the other, feature implemented. And then later say, oh, but couldn't you use the transfer funds to method? Yeah, let's do that refactoring. I forgot we had a method in the actual bank account class. Okay, right? The feature was implemented. There were specs describing the feature. I implemented it one way, the test passed. As I review the code, maybe another developer doing a code review say, hey, dude, why are you doing withdraw deposit? Why don't you just call, transfer funds too? Oh yeah, you're right. There we go. We'll make the change. The tests are still passing. You're good, right? Excellent. Next step, as you start thinking about this, like, okay, what are the chances that this thing could fail? What if one of those accounts does not have sufficient funds for the operation? What should happen then? Because it's going to throw an exception. It's going to break the loop. Now what? Go talk to the PO, right? It's like, well, we don't know. We don't have any acceptance criteria for that. Oh, you can just put an if block there and a try catch. It's like, no. You don't do any of that. That's an exceptional case. It's a very valid one. It could happen. It's very likely to happen. Go talk to the business and say, hey, did you guys think of this scenario? It could happen, right? Yeah, you're totally right. Thanks for bringing it up. Let's sketch that out. What should we do? Should we accept and just transfer what we can and let the user know? Or should we halt the process and say, no, we can't because of, or should be that something configurable, right? We let the user decide, is either, everything or nothing, or can I do it partial? Let's have the conversation before we write code, before we change things, have the conversation first, right? So, and I think I've put that like in a, sometimes I drop like to do comments around my code. And then when I ask people for, can you do a code review? I'll run through these things to make sure that we have the conversation. And if there are actionable items, they end up in our backlog, because then the product owner might say, that's a very great point. We are not going to be able to do that this sprint. We shouldn't do it because it's a new feature. I'm adding a user story to the backlog, and we're going to prioritize when it's time. But thanks for bringing that up. Okay, good. We keep moving, right? Almost there. All right, almost wrapping this up. So now we have these beautiful folders there. Instead of, yeah, the next step. So what I did was, since we've gone from having a bank account class to also now having a transfer funds or transfer service, instead of having bank account specs, I renamed that to banking, right? Because it doesn't matter whether we have a bank account class, a transfer service class, and a million other classes. Because at some point, somebody might say, you know what, we have a bank account class, but now on the new tests, we are talking about savings account and checkings account. Shouldn't we model that? Shouldn't we have a savings account class and the checking account class? Well, yeah, maybe we should. Oh, and that isn't that all part of banking? Yeah, you're right. Right? So do not think about the actual implementation. Think about the why do we have those things. In this case, banking, depositing, transferring. As you look at those features, right, when you open those context files, it will show you, oh, for this one, we use this class. For this other one, we use this service. For this other one, we actually call to a third-party API that gives us that service. Okay, it's all good. But the description of them is abstracted in a way that makes sense from the business perspective. Also, I normally don't work with the Solution Explorer thing to find my way around, because in projects that are large, it's nearly impossible to find your way around, right? So what I do is, most tools, you can hit Control-T or whatever the key code combination is to look up things in your project. So let's say that I want to find, how are you doing when we're doing banking, how are we handling the withdrawing? I hit the shortcut and I type bank/with. I don't even type the whole word. The tool will find it. It will match the folder where you had the feature described and the class with the context. Like, oh, that's exactly the one that I'm looking for, right? You open that file, it will show you, oh, here, we have an account and we have a withdraw method. You start learning from the outside in like this. Once you found this context, it's like, oh, that's great. Now let me see the context, the scenarios that we have for this feature. Most tools will have a shortcut combination to take you to the file explorer, right? Where you would be able to see, oh, what are the other files that reside in the same area? Oh, cool. For withdrawing context, daily limit, fraud victim, invalid amount, line of credit, it's all there. So it's much easier to navigate a project like this than going through, a variety of, deeply nested folders and files and all that. So we can walk around and, learn about the system and the business as we go. I do a lot of this kind of search. It's like, okay, I'm searching for banking, transferring multiple accounts. I usually don't type the whole thing. Bank, tran, me, like MU, right, for multiple. I type just enough for the tool to actually pick up. It finds exactly what I'm looking for. I don't have to think about, is this a class? Is it a method? Is it a property? Is it a service? I don't know. But I know the business terms from the ubiquitous language, from DDD and all of that we've discussed with the business. I've brought that into the code base. So I can use that when I have to go into the code base to learn, what do we currently have? How is it described by specs? How is it implemented? Right? That's what I have to remember. I don't have to remember whether it's in a controller, a handler, a validator, an entity. I don't have to remember any of that, right? I just have to remember the actual business concepts. We get there, we do all of that, and then wrapping things up finally. So we have a couple more minutes for questioning. I've put out an article on the Improving's blogging page called Context-Based Testing, where I go like high level on what we've covered here. If you would like to share that link with other people to start maybe, advocating this kind of practice. The implementation varies, but it's the same approach. As I said, I used exactly the same approach in C#, Java, JavaScript, TypeScript, Ruby. It doesn't matter the language, right? I use exactly the same approach. Whether you're using MS Test, NUnit, XUnit, Jest, Jasmine, you name it, same approach. Cypress, right? I do a lot of work with Cypress IO for end-to-end tests. All of my tests are described exactly the same way. You switch over my tests from front-end, back-end, unit tests, integration tests, end-to-end tests. They all look very similar. The languages are slightly different, but the bulk of the test, it looks very similar, and the organization, very similar. Both business and technical code. So it's not just for the behavior of business features. If I'm creating something that's highly technical, maybe I'm creating like a text parser, right? That's very technical. I'll still describe it as given when then. Given the text file, when I parse that file, then I expect the following thing. I still use the same English to describe whatever, right? So there's no distinction. Oh, no, this is just a technical thing. I don't need to. No, you do. Because even that technical thing, there are different contexts under which you're going to be using that technical thing. I want to know what those contexts are, because if I'm planning on using the thing that you created, let me see how you're describing. What are you supporting? What have you designed that thing for? Your spec should describe that. Okay. Have that. Why? Value of the discipline, highly visible to the business. Right? I share this a lot, even like in sprint review. I share little bits of tests with the business, and they're like, oh, that's how you guys are doing this? That's awesome, because we're currently going through a problem where developers don't understand what's implemented. Now that we business people understand, they see that. They advocate for the practice because they see the value to their business. Huge dividends for developers. Writing new tests becomes so much easier. Fixing or changing what's there becomes a lot easier because you look at the code, it's like the test, like, okay, got it. Let me go in and make the changes, right? So it pays, big time. I'm gonna open up for questions that come up. Make sure to check out, I also run the virtual brown bag, which is a meeting that happens every Thursday from 12 to 1 Central Time. Tony is always joining us when possible before daily stand-ups and all that. But it's essentially an open forum for discussions on things that come up. Always lots of good, productive conversations. Improving offers every Friday at noon some free lunch and learns. We call it our Improving Talks. If you go to improving.com/virtual events, you can see what's coming up, as well as the links to the previous talks that we have up in our YouTube channel. Classes that we have come up in the Scrum space, in the Agile space. We are currently hiring. If you're interested, send me an email and I'll hook you up with the people you should be talking to. And other than that, okay, what are the questions? Sorry, I talk a lot. This is a topic that I really, really like. Yes, sir.
It's kind of newbie questions, but how do you, can you show us a little bit how you set up when you're checking that the when show an exception? Because I usually do the assert right there on the code. You don't, you do it on the
Yes, beautiful observation. So I'm not sure the folks on the call heard. So how do we do when we throw exceptions? How do we test that? And the way to do it, like all of these assertion frameworks, like fluent assertions, if you're not using and I said I'm using plain C# here. I guess one thing that I'm using that's not plain C# is a library, a NuGet package for the assertions. There are many out there. The one I use, I think it's called Fluent Assertions, but it gives you like should extension methods, where you can say this value should be this, or like here, this action should throw this exception, right? So instead of calling the exception directly and putting an attribute at the top of the test method to say, hey, this test should throw this exception, I like this way of saying, okay, this action here, when it is called, it should throw this exception. So then I can write my, so if I, oops, sorry. Like, remember that the actions I am not calling them here. I'm saving them as a delegate, right? So it's just like a name memory or a memory pointer to a function. So I'm saying whenever I'm trying to invoke a deposit operation, this is the code that I need you to run, right? And then later, so like here, I just say, hey, deposit action should throw this. What is deposit action? Is this little bit of code here, right? So because of the way delegates work in C#, whenever we call this, it's gonna call this method here. And if that throws an exception, this should throw. That's the thing that's wrapping that code into a try catch. So it wraps that code into a try catch, and it makes sure that the exception that gets thrown is of this type. If we get a different type of exception, this method here will just say, well, we didn't get the exception that you're looking for. Does that make sense?
Yeah, show the implementation of when trying.
Yeah, let's see. Do I have it here? Oh, when trying. When trying, I'm just only saving the amount. Exactly. Yeah, so that's the thing, right? I have these givens to capture information, right? I'm not actually executing anything. I'm just capturing. What is the amount? What is the initial balance? What is the thing here? Capture everything. And then on my when, that's the time when I have to, everything that I've gathered, let me pull it all together and actually call the method. So up here, remember, account deposit, and I pass in amount. Well, during the constructor here, amount is not, we don't have anything yet, because that happens when trying to deposit, how much? Oh, 10. Then there we assign it to the amount property. By the time we call the delegate, it has that value, and then it's all happy, right? So givens, you're collecting what you need, not executing them. When, that's when you actually trigger the behavior that you're trying to test. Cool? Already? What else? Any questions up there? You guys, wake up! Folks online, wake up! If I shake
Pablo-
my computer,
Pablo's
is it
watching
gonna
soccer
shake
game.
your desk as well?
I think Pablo's still watching football.
No. I've been paying attention. I've been paying attention.
Must have been a slow game.
Awesome.
No, I think I kind of really resonated with your point on, not kind of, but really. I've tried to do Gherkin script, or I've seen projects that do it, and it's just, it feels like it's a lot more work than it's worth. And it clouds you from being able to easily explain, like, okay, how do I write this test? Because you're trying to figure out, okay, this sentence, what code provides the sentence and how is it put together? I like this being executable. It's a tool, and it's like you said, it's easier for you to work with the person who's in the business and say, here's what I'm doing. Does this make sense when I read it to you? Rather than, they're not going to write it themselves, right? To me, that's a fiction.
Yes.
It's really going to be a developer working with them to build executable behaviors.
Yeah, that's been my experience too. We've put together all these tools and everything so that non-technical people can write these things. They never do. Right? We developers are the ones that end up managing it, right, and maintaining it. So yeah, that's why I also advocate for not having overly descriptive gherkins, right, where you reach way too deep into the thing. You get way too granular into the feature. It's like describe it at a more high level so that you can keep the conversation going. Because the people who are doing like the test cases that have to be very thorough, the test cases, you can go as granular as you want. Here, we're just trying to keep a conversation flowing, right? Keeping more at a high level, to make sure that we are aiming at in the right direction. So that's good. Let's see, Tony, you had a question.
So I was going to ask you, how would you go about this current your current? Let's say you have code base, very large code base. It's different though. Teams all of this.
Mhm.
and checks reject anything that's underscores.
Yes. Did does
No,
did everybody?
I was gonna ask if you can repeat the question because we couldn't hear it.
Okay, yeah, I couldn't say couldn't tell if you had a.
I'll type it out. Chat.
Yeah, so if I got a gist of it, how do you do something like this in an existing client or project or institution where you have already a legacy large system with a lot of tests written in, just following a range access assert with code coverage up to say 80%, and with gated policies like checking policies that will reject submissions or code that has underscores, lines of code that have underscores and things like that. Yeah, so that's a very pertinent question, because what happens is, yes, if it is a legacy system, right, and with a legacy organization, I'm not going to dive in and say, okay, you guys are doing this all wrong. This is the way to move forward. No, that's not my jam, right? My jam is to come in and understand, okay, let's look at what we have here. All right, let's start making small, like show them where the pain is and start introducing some of these practices over time. Like if people are valuing code coverage just because somebody has put a policy in place to say every time we commit code, we have to have at least 80% code coverage. Okay, let's talk about that, right? Because that code coverage alone does not give you what you want, right? Or even more important, what you need. So my main point is I work with the organization and with the people involved to see where they are coming from. Because if they have code coverage policies like that, first I'm going to need to find who put the policy in place, understand their motivations, and find ways to politely educate them into why doing it in that manner is not ideal for their business. It's not really buying them what they think it is, right? So sometimes it takes time. It has taken me like months to be able to earn the trust of the people who make those calls, to actually show them, hey, look, this is how we should be doing. It takes time. It does not happen overnight. If people go like, oh, underscores in our C# code, heck no. Okay, all right, I will conform with your guidance, but I will take out of my own time, like say I have like this one large test that is following the C# design guidelines, which is going to look atrocious. I show that to them, right? So I may refactor the test. If they have a bunch of arrange act assert, I'm going to refactor it into the given when thens, following the C# conventions. And I'm going to show it to them. Let's start with the language. Do you guys understand this? Look, we had this arrange act assert with all these like mocking and stubbing and stuff. Can you follow this? They will go with, nah. What about this refactor version? Well, that still looks kind of odd, but yeah, I can actually read that. Okay, what if I make everything lowercase and I put the underscores there? Oh man, that's so much better. I can actually read. Okay, let's talk about that. Right, so show them the pain, show them, right, the benefit, the value. It's not just this is how I do it. That's not going to buy anything, right? You have to learn the people, learn their background, where do they come from, right? What kind of pain have they had in the past that maybe justify their current way of doing things, and then find ways to alleviate that pain and show them that there are better ways to go about it. So to me, like the larger the organization, the longer the process, and it is just what it is. But I have worked at companies like for long enough where I've made progress with getting like some of their key lead developers to buy into this practice, and then the thing spreads. Right now, they start coming back saying, "Oh, can you teach more of our developers into that practice because they're liking that way of doing things?" Yeah, by all means, let's do it, right?
Question in the chat from Jim.
Okay.
Any strategies for avoiding duplicating tests, and also any techniques for knowing you haven't missed the critical test?
Duplicate tests. I am not, if we are organizing tests in this manner, where we think about the feature and the scenarios for the feature, they should all be sort of like grouped together. So it should be kind of easy for people to see tests that are duplicates, because they should be named very similarly because of the context. So that would be one way to look at it. I wouldn't be, if the tests are organized that way, and we do have testers like, oh, they look like duplicates. If they end up being duplicates, I'm not too concerned with it, because it's just, more exercising of your code through tests. That's okay. Now, if they are adding ambiguity to understanding what's there, so yeah, let's read these tests and understand, why do we have two of them, right? Are they real duplicates, or maybe we're missing something in there, right? So again, begs a conversation. The other point was the missing some critical ones. I love that one. So like one spot, like working with a legacy system, large databases, when people start thinking, oh, we would like to change some of our tests into this format. Should we go ahead and redo everything in this way? It's like, no, right? The way I normally do it, and this is what I tell people about like code coverage. Use code coverage to protect the most important features that you have for your business. So I say, what is the number one feature that if it's not working, right, if it has a bug or something, you're going to either lose money or you're not going to make money, right? If it's preventing you from making money because the feature is not working properly, show me what that feature is. Oh, it's this thing here. All right, let's make sure that that thing has at least 80% code coverage. Just that. Okay, how do we achieve that? Well, how about we look at the current tests, we see what code coverage is at that point, and we start refactoring those tests to make them better, and then we fill in, okay, what are the branches of the code that we are not hitting? Are they different contexts that we are not testing? Now let's write tests for those critical pieces that were not tested before, that were not covered by tests before. Get that out of the way, move on to the next one, right? With nobody, I go with the, oh yeah, we need to have 95% code coverage on everything. Nah. Another talk that I share with people, the process that I have on my teams, where if we have, I want to have very good, very high feature coverage, and on the most important features. If the most important features for the business have good coverage, I'm good. Whether that's 100% or 95% or 90%, because maybe even within a very important feature, there is a chunk of that feature that's like, it only affects 1% of our users in the bottom end. So it's not that important as much as this other thing here. So I use those to gauge our testing efforts, right? So like I just looked at the current project that I'm working on for like 12, 13 months now. I had never looked at code coverage numbers until 2 weeks ago. 2 weeks ago, I decided, okay, let me see if my theory really holds true, because I know we have feature coverage. Why do I know? Because the team discusses during sprint planning and refinement, what is the acceptance criteria for the story in given when then terms? What are the cases, the scenarios? What are the steps? We discuss that, and we all practice writing the test before implementing the feature. So I know that we have feature coverage, and that should take us to a high code coverage. Okay, let me see the numbers and see if that holds true. Yeah, it does, right? So I saw things like in the backend side of things, 92% code coverage. Now, for the entire project, if I look at the part that I really care about, or that I care the most about, which is the domain implementation, where we do our DDD and we have our bounded context and all that, I saw close to 100% there. The parts that are in the not covered, it's like some helper functions that somebody dropped into the project and we're actually not using. I'm like, I don't care that that thing is not getting covered. And I don't want people writing tests for the thing that does not have coverage just so that we can satisfy a checking policy. That would be lame. Like, why are we spending time on that? So that's why I start asking the questions. Hey, why do we have those policies? Right? Can we revoke some of those policies because they don't make sense? They are preventing the team from being productive and from delivering the results that you guys are paying us to actually achieve. Yes, sir.
So this is along the line. You start having to use boss and spots.
So when you have mocks and spies, how do you use that in this format? Same way. So my given, if I say given product is in stock, how do I represent that? Well, maybe it's a mock, because in order to figure out whether the product is in stock, we have to call this microservice here that gives us that information. Okay, mock that thing and say there's going to be a call into this thing that we use to interact with the microservice. Hopefully we're putting an interface in front of that, right? And then we mock that because we're going to set a spy, or in this case, just set it as a mock to return a stub to say, hey, when this method gets called with this parameter, just return true. That indicates what? Well, the given is telling you, given the product is in stock. Okay, this is how we have that information, right? Then the following thing happens. Like then, a product is set as back order. Okay, how does that happen? Well, maybe it's not code that we wrote, it's another API that we call. Okay, and that then you're gonna, set some sort of spy to say, hey, has this method has this message being sent to this microservice or to this API or to this other thing here, right? So my then, instead of looking at like spies and stubs and stuff, it's like, no, give me a description. What are we doing here, right? Oh, we're verifying to make sure that a method or the product has been set into like back order. Okay, that's a good description. How is it implemented? You look behind. Well, right now we're calling into this endpoint. 2 sprints from now, now we own that code. We implemented something that does that. Okay, the description does not have to change, just internal implementation changes. Okay, so yeah, thanks for bringing that up. I do have to revamp some of these examples to use, like mocks and stubs and spies, but they all fit into the same, I do exactly the same thing for those as well. Welcome. Excellent. That it? All right. Thank you guys very much for having me. That was fun. I love talking about that. If anything else comes up later, make sure to write down my email there and just reach out.
All right, awesome. Thanks so much for hanging on. If you want a prize, Garo probably reached out. Please send us your information so that way we can send that to you and contact you. Thanks again, everyone. We'll see you guys later. Thank you. Thank you so much, Claudio.
Thank you. Bye,
Thanks,
everybody.
Claudia. Thanks, everybody.
You guys keep safe, okay? On your way from your desk to your bed.
To my free sandwiches.
There you go.
Thanks. Bye.